Alright, everybody. So, welcome to Data Science Masterclass. My name is Emmanuel, and I'll be taking you through this class, all through the installation of all the necessary softwares and packages you need to have. And I will make you to understand these things as simple as possible from the real world point of view because I'm really interested in you building a career here. So we are going to have three theoretical explanations, three different PowerPoint slides before we go on to the coding and all. And I want you to really understand every single thing. Don't jump, understand every single thing. Follow everything line by line, ask questions. Alright, this is very different from other online programs you take where you don't get to ask questions and all, but here I'm providing everyone who have subscribed for and registered for this my class the opportunity to ask questions and get them answered. So I promise you will enjoy this course. Alright, so let's go on. So as I said, I'm going to take you through what data science really is. Then after this, I'll go through the different data science libraries, then the different life cycles for data science. When you are dealing with any data science project, how do you go about it? So there's a life cycle, there are stages for you to go through for whenever you are handling any data science project or task. All right, then after that I'll take you through some Python basics, just some Python basics tailored towards what we are going to be doing, and I've already delivered some full folder kit. I call it the boss kit. So you have to unzip all the files, unzip the sub files, and everything for this program. And then after the Python basics, I will take you through the libraries again. Then I are going to do hands-on coding and all. Then after that, we should go through at least two projects. We're going to build a movie recommender, then a spam classifier, or another project I was thinking about. So, but we're definitely going to build a movie recommender system and all. Then this will interest you if you are going into if you are into digital marketing already. This will be very helpful for you. You'll be able to analyze companies' data and provide marketing insights for them and all. So consider that as a plus for you, a digital marketer. All right, so let's jump right in. What is data science? Now, this is my definition for data science, and I broke it down for you to really understand what data science really is. Now, data science is simply the process of exploring and understanding historical patterns and using it to create a model to forecast or make accurate predictions. All right, that's the for accurate predictions. And here you have data is the oil here, as you can see, and we are going to be in this data science masterclass. Python is going to be our major tool here. We're going to be using Python as our major programming tool for exploring and manipulating data and modeling and all of that. So it's simply the act of playing with data. You visualize data in order to gain insights into your data, and just think of it as using the explored data, right? After exploring data to understand the data, using that explored data to model a lasting solution that will be able to think by itself and make predictions by itself. So actually, it's a grand foundation for that leads to machine learning and deep learning. So going over it again, data science is simply the process of exploring, manipulating, visualizing, and understanding historical data, right? Historical data patterns. You are going through historical data, so you can understand the patterns there. You can understand the trend of how things have been, to understand behavioral trends in historical data, and using that result to make accurate or nearly accurate predictions when faced with real world situations. And you use it to forecast outcomes. So basically, so just see it as the art of playing with data and all to provide business solutions or others. Then, like I said in the previous slide, um, you use you explore data to build models. And what exactly is a model? Just think of it as an equation. All right, x plus 2y equals to 2 as an equation. So you build a model based on your data exploration outcome, that is after understanding the patterns of your data. Then you train that model with your data, and then you go ahead, after training a model, you go ahead testing your model on new data, new real world data that it has never seen before. It's just like you training your brain, right? A small child. As a child grows up, your child gets to understand, and your child gets to understand the differences between colors, animals, and all of that. Your child will be able to say, okay, this is a dog, this is a cat, and all those things, they came as a result of training. All right. So you can actually train your model. You can actually train a, just call it a brain, for instance, or an algorithm, to be able to identify dogs and cats and distinguishing between dogs and cats by training it with hundreds of the respective pictures. So you train your model with hundreds of pictures of dogs and cats. So your model is going to be trained with these pictures. Then when you bring this is mostly used in you can implement something like this using computer vision. And I just rounded off the face recognition masterclass. I advise you to actually go back and take that class if you really want to understand how this works. So you can identify, so your model can actually get to see, we using computer vision. Then you can see, you can actually present a real life dog to your model camera, and it will be able to identify and say, okay, this is a dog, this is a cat, or this is a dog, depending on the. And you should know that for making predictions, your model accuracy largely depends on your training data. So in your data, you have two of them. You have a data, and then you have two types. You split your data into two. You have your training data and your testing data. You use your training data to train your model, and your testing data to test the accuracy level of your model. So what are the steps for carrying out any data science task? So first of all, when you are handling any data science project, any data science task, what are the steps you take? First of all, what do you want to do? You have to define that. What do you want to do? You want to solve a problem, right? So you define the problem and you hypothesize the solutions, possible solutions for solving that problem. Okay? And then for in order to do that, you have to use data. Remember we said data is our oil here. So you have to work on data. You have to explore data and all of that. So you have to locate databases where you can collect data and all. And there you check for you also check, you validate your data and all. You prone for anomalies. The reason is because you don't want those anomalies to affect the result of your data. Whereas normally when you collect data, they are data when you collect your data, they usually come messy. All right. Sometimes you might get just think of it as an Excel sheet where you have a lot of missing values, inaccurate values. You have a lot of missing values and all of that. Mixed value types, data types, where you have some of them you have numerical values, some you have categorical values, and it's always good to bring everything to the same value data type for easy analysis and treatment. So you normally have data like this in a messy manner. Sometimes you have your data in different formats, and so you have to bring them back to the same level format and all of that. And sometimes you might have outliers. For instance, if you are dealing with, okay, if I should give you the data of those of you who paid for this class, you will see people um, who paid certain amounts, right? Then let's assume someone among the customers, one of you paid, let's say, 1 million naira for this master class, right? Out of everyone who paid, for instance, 4,000 naira. So that is already an outlier, right? It's an anomaly. Like, it's far different from all other value range. Just imagine you are having 4,000, 4,000, 4,000, then you now have 1 million. That is very, very large. So if you get to space your data, you're going to see how far away that data point of 1 million is going to be from. You are going to see the standard deviation, how much it deviates from the mean and all of that. So you can get to see that in data science we deal with statistics also, right? So you get to analyze your data, explore your data. So you are just understanding your data to get insights and all. So you get to visualize your data, and visualization is very cool because you get to work with graphs, diagrams, charts, and all of that. So it's very advisable at every point visualize your data to see how it is. You space it in a graph, plots as you are working in the course of exploration, even after prediction and all of that. And then you get to build models that can predict based on historical patterns, right? Then you act, that is, you make decisions based on your analyzed data, like changing marketing strategy. Maybe after working on the company's data from their database, you can now propose solutions like, okay, they should change their marketing strategy, or they should increase their budget for a particular activity, right? Or they should focus on a geographical area, like they should focus more on Lagos instead of Abuja, Lagos, Delta State, and all of that. They should focus on Lagos. Then specifically, they should focus on Lekki, because from the history of their data, most of their buyers came from Lekki. So that's it. So that is basically what you do. So, and this is the most important step, because most companies, they don't want to see how you analyze the data. They just want to see a very clear report of what you did, the outcome of your analysis, and they want strategic steps, actionable steps to take to increase their cash flow and all of that. So what data scientists do, they detect anomalies, for instance, abnormal customer behavior, fraud, and all of that. So in my I have a Paystack account, and I get to the and my and the account I have, it gets to one of the features there is a fraud detector, and it gets to detect frauds and all of that. If someone was trying to um, get into my payment gateway illegally, so it will get to alert and all of that, right? It's an abnormal customer behavior, so that would be an outlier, right? So it will get to alert you and detect that. So it also for personalized marketing like personal email, newsletter, especially retargeting, right? You can retarget like on Facebook. On Facebook data, for instance, you have different many users, each with respective locations. When targeting your ads, you can get to target your advertisements to focus on a particular geographical area. So that's all data science. You can use it to make recommendation systems. I trust you've gone through YouTube and you've seen something like this, videos recommended for you or friends that you may like on Facebook. So these are all parts of they all come from data science, right? And I told you data science is a ground foundation. So you can use it for metrics, forecast, performance indicators, quality of advertising campaigns, and all of that, for scoring systems, to process large amount of data, to and most especially to help you make decisions, right? Then also note for data insights. Okay, and this aspect of your data science is all about uncovering findings from data, because you are exploring a large data set to uncover insights and findings. All right, so you want to understand different complex behaviors, trends, inferences from data, and all of that. It's all about surfacing hidden insights that can help enable companies make better and smarter business decisions. Okay, so for instance, now Netflix determines, for instance, Netflix data they determine movie viewing patterns, right? Why do they do this? Now they do this to understand what drives user interests, and they use that to make decisions on which series to produce actually. You can see in a recommender system, after understanding the different all your like history and everything, they can recommend a movie for you and say, okay, since you've liked a movie like this and this, you would probably like this movie because other people have liked these movies too and they've watched these movies also, so you may probably like this one. So they use all those things. They use buying data, those who bought, those who commented, those who liked, or maybe from the posts you comment on Facebook or other platforms, they get to push some kind of information to you based on your interest. So they use different ways to get your interests, to get interest data from you in order to help serve you better. Right, so for data products, for instance, the Amazon's recommendation search engines, they suggest items for you to buy determined by their algorithms. And Netflix also recommends movies for you. Spotify's Spotify recommends music to you and all of that. So that's what happens for recommendation systems. Then for another, a Gmail spam filter is a very good data product, and it has an algorithm behind the scene that actually get to sort out incoming mails into spam and inbox. So a spam filter to be able to say, all right, this mail is a spam, this mail is not a spam. And the model and the algorithm that actually work behind the scene are usually trained with thousands of sample spam messages and sample good inbox messages. So when there's a new incoming spam, because of the training, it will be able to predict and to be able to detect which is a spam or not. Then you have computer vision used for self-driving cars, and it's also a good product. And you see that you can use machine learning algorithm, like for a self-driving car. Like a self-driving car can get to recognize traffic lights, the red, green, yellow, and all of that. It can get to recognize other cars on the road. It can recognize road signs and everything on the road as well. So just see this as how a brain works. It gets to understand data, understand past history, understand patterns in data, and looking for ways to forecast, looking for ways to predict and make accurate decisions. So that's all for the introduction for data science.